Okay, two very good strategies to adopt when you solve kinematics question is to, number one, write this down so that you can refer to it easily. Number two, draw a diagram, okay, based on the question content given. So a motorist traveling at a constant velocity of v meter per second pass by a fixed point O. So what I do is, once I read this, I draw one line and I mark here X, okay. Saw a few vehicles ahead. He stepped on the accelerator and his subsequent velocity is given by this. Okay, so I wrote this down here, or you can actually box this up because this is a very important information given. Okay, this is your velocity v, where t is the time in seconds after passing x. Now this statement is important because from here you know that the time here is 0 because you only start timing in seconds after the vehicle pass point x. So this must be t equals 0 and s must be 0 here also. Okay, because this is your fixed point that you are measuring from. All your other points, and in this context is the y, is measured with respect to x. So the s here, that means the distance from the fixed point is 0. Alright? Now, as he passed point y, which is, these are the point that I've labeled. I just label on the right. Now you will say, why not label on the left? Normally for O level we label on the right, but if you later get an S that is a negative value, then you know that, oh, actually it's on the left, okay? But by convention, we just label on the right first. They normally don't make things difficult for you, okay? Its velocity has increased to twice. That means the velocity here has increased to twice the velocity here. Now, I've written here 60. How did I get 60? From this velocity equation, I sub in t equals to 0. Okay, anything to the power of 0 is 1. Then I get v equals 60. So this is 60. Twice of it is 120. Okay, so that's how I get 120 here. And do I know the s here? Actually, I don't know the s here. So I just leave it, not to worry. Alright? Find the time taken to travel from x to y. So from this diagram, you can see very clearly that at x, the time is 0. At y, you can actually use this v equals 120 and then find the t from here. Okay, so this 4.1589 is actually obtained from solving this equation. Now I want to highlight something very important here, and that is how to solve this equation. Now, some of you are still taking ln both sides immediately after this step. Cannot, okay? You have to make sure that this is 1, then you go and ln. That means this must be 1. Okay, so you divide both sides by 60, you get 2 here, then you go and ln. Alright? Then once you ln it, you bring down t over 6, this is 1, and then you times 6 both sides, you will get this answer. Please show the 5SF value because in the later part of the question, you will need to use this 5SF value. Okay, so that's how I get this t value as 4 point something. Okay, now let's move on to the next part. Find the acceleration. So from here, you know that if I want to find acceleration, I have to differentiate the velocity. That means I differentiate this. So differentiate exponential function, just photocopy whatever you have. Okay, you see I photocopied 60e t to the power t over 6, right? Then I differentiate the power. T over 6 is just 1/6 t. Okay, it's just 1/6 times t. So you differentiate 1 over 6 times t. Power bring down, power minus 1 and all that, you just get 1/6. Multiply the two constants, you will get this. So this is your acceleration formula. Sub in this timing and you will get this answer. That's it. Again, leave it in 5S. Show the 5SF value, but leave the answer in 3SF. Okay, and remember your units. Okay, last part. They ask you to find the distance xy. Now, This is where the diagram really comes in very useful. If you had drawn a well-labeled, well-updated diagram, then this part is really a breeze. To get from x to y, you know the s here is 0, so you just need to find the s here. Okay, now you may ask me, will U-turn in between, in between 0 and t equals to 4.1589, would it U-turn? Would it stop somewhere to U-turn? The answer is no. Why no? Because if you look at this S, where's the S? Okay, sorry, I haven't found S. Okay, so to find S, right, I integrate the velocity. Okay, so integrate, I just photocopy this, then I differentiate this and I divide. Okay, so please don't be confused. When you integrate, you divide. Just now when I differentiate, I times whatever I've differentiated at the power here. Okay, so please do not get confused in the exam. A lot of students are confused in the exam and then lose marks. Okay, so this is your S. Okay, and how do I find the C? Again, you go back to the initial condition. That's why you see this diagram is so powerful. Everything can be obtained from this diagram. When t equals 0, s equals 0, right? So you sub when t equals 0, s equals 0, and you get c equals minus 360, and that is your formula. Okay, now why do I say that this vehicle will not stop? Alright, will not stop. So if you were to look at number 1, the B equation, if I try to sub this equals to 0, right, I will not be able to get any answer. Okay, as in you will find that there's no value of t after this initial timing where it's actually 0. Okay, so it does not U-turn at all. Okay, and also looking at this thing here, the only time that the s actually there's no time where the s is decreasing. This is an increasing function. Okay, because when you differentiate this you will always get a positive value. Okay, so this is an increasing function. If you were to draw the graph, right, it's going to go up, 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 up. So it's never going to U-turn. So this actually tests you on your understanding of this exponential graph. Alright, so it will never U-turn, and because it will never U-turn, right, what the vehicle did was it traveled straight from x all the way to y. And because that is so, okay, so you can just substitute t as this into the s equation, which is what I did here, and then you get this, and that's your answer. Okay, because down here this value is 360.000 something, right? So it's from 0 to 360.00. So the x distance x to y must be 360. Okay,